So in the last video, we talked about how elementary row operations can affect a determinant. So let's talk about where this could be beneficial. Where would you really want to try to use this? Well, we know finding determinants of 2 by 2 and 3 by 3s are easy. But if we get to something bigger, 4 by 4s, 5 by 5s, 6 by 6s, and so on, it can get a little tedious and a little challenging, especially if there's not a lot of zeros in the matrix to cut down on some of the work. So, it may be beneficial to try this method instead. So our goal is always going to be to turn this into a triangular matrix. And then once we get it to a triangular matrix, as long as we're keeping up with those row operations, we'll know what happened to that matrix's determinant. And then we can kind of undo that to figure out what the determinant of the original matrix is. So every row operation produces a matrix that's row equivalent to the previous matrix. So we're going to kind of keep track with all of that as we go. So let's look at an example. Let's look at this guy. We want to find the determinant. Now this guy's a 4 by 4. It's not going to be terrible to do it by hand, especially since we have a 0 here. We could go across the second row, or we could expand across that third column, and we could get it without too terribly much work. But let's use those properties to help us do that, and we're going to practice those as we go. So remember the goal. Let's turn this into an upper triangular matrix. So we can start by taking row 2 and replacing it with row 2 plus row 1. That's going to get rid of this negative 1. And then we can take row 3 and replace it with row 3 plus negative 4 times row 1. Now we'll get rid of this. And then we can take row 4 and replace it with row 4 plus negative 5 times row 1, which will get rid of that 5. So if we do that, we end up with this matrix. So let's think about what happened from matrix A to this one. How did the determinant change? Well, if we look at that first row operation, it was replacing row 2 with row 2 plus a multiple of row 1. So the determinant's going to be unchanged from that row operation. Row 3 was replaced with row 3 plus a multiple of row 1. So once again, the determinant's unchanged. And then row 4 is going to be the same way because it was replaced with row 4 plus negative 5 times row 1. So in each of those steps, the determinant was unchanged because of the row operation we chose to use there. Now if we look at this matrix, this matrix will actually have the same determinant as that original matrix because of the row operations that we chose. So it's always nice if you can use that, replace a row with the sum of that row and a multiple of another row, because it will never change that determinant. So now let's continue our process here. We don't have to go into REF. We can choose to keep other numbers down the main diagonal, but the goal is always to get to a triangular matrix. So my next step, I'm going to try to zero out this guy, and I'm going to zero out this guy. So I am not going to turn that 4 into a 1. We could if we wanted to, but it's unnecessary. So now let's take row 3 and replace it with row 3 plus 5/4 times row 2. And when we do that, just looking at these entries, so row 3 is negative 5. And if I add 5/4 times row 2 to it, I'm adding 5/4 times 4. And that will give me the 0 that I need in that slot there. And then let's think about what row 4 is going to be. It's a little bit harder to come up with this when you don't have ones in that leading spot, but we can still do that. So row 4 is going to be row 4 plus 17 over 4 times row 4 times row 2. So if we look at what that's going to look like, so we're going to have negative 17 plus 17 over 4 times that 4 here. So negative 17 plus 17 will give us that 0 that we need. So be careful setting these up. And be careful when you type it in your calculator or you try to reduce it by hand. So rows 1 and 2 are going to stay the same. So negative 5 plus 4 times 5/4 is a 0. Negative 10 plus 5/4 times 3 is a negative 25 over 4. And then negative 15 plus 5/4 times 1 is a negative 55 over 4. And then if we compute that last row, we're going to have a 0, 0. So then negative 18 plus 17 over 4 times 3 is negative 21 over 4. And then negative 12 plus 17 over 4 times 1 is negative 31 over 4. Our next step is to zero this out. Now we've got a lot of fractions in here. This could get complicated if we want to go straight for that to begin with. So here's what I'm going to do. I'm going to first take row 3 and I'm going to replace it with negative 4 over 25 times row 3. Just so I can get a 1 there, just so that last step's going to be a little bit easier for us to see. I'm going to have a 0, 0, positive 1, and (11 over 5). Now, before we do the last step, let's talk about how the determinant has changed. So if we go back to this step, row 3 is equal to row 3 plus 5/4 row 2. The determinant is unchanged here. Same thing is going to be true for that next step for the exact same reason that it was unchanged in that first step that we did. However, when we took row 3 and we multiplied it by negative 4 over 25, we changed the value of the determinant. The determinant is now changed by a factor of negative 4 over 25. So this guy has a different determinant than that original by a factor of negative 4 over 25. Which means that when we find the determinant of this guy, we're going to have to undo what we just did there. So now let's look at our last step. So we're going to take row 4 now and replace it with row 4 plus 21 over 4 times row 3. First 3 rows are the same. So we're going to have negative 31 over 4 plus 21 over 4 times 11 over 5. And that's 19 over 5. Now, how did this change the determinant? Just like the previous steps, we took a row and we replaced it with that row plus a multiple of another row, so the determinant's not going to be changed. So I'm going to call this guy matrix B. That is my reduced to an upper triangular matrix. So the determinant of B is equal to the product of the entries down the main diagonal. So our determinant is 4 times 19 over 5, which is 76 over 5. Okay. However, remember, that determinant got changed. The goal in the beginning was to find determinant of A. And when we performed this step here, we ended up changing that determinant by a factor of negative 4 over 25. So we have to undo that. So our determinant is going to be 76 over 5. And to undo multiplying by negative 4 over 25, we're going to multiply by the reciprocal, negative 25 over 4. And that's going to give us a determinant of negative 95. So the determinant for A is that, which is the original matrix, is going to be negative 95. Let's look at one more example of those. Let's say we want to find the determinant using elementary row operations. So what that means is we want to take this matrix, it's a square matrix, and we want to do row operations until we get a triangular matrix, and then figure out how those row operations will affect the determinant. Remember, the goal is to find the determinant of this guy. Now, this one is a 4x4. This one would not be very nice if we wanted to expand. There's no zeros, so there's no shortcuts on this one. So let's get started. First thing I'm going to do is I'm going to interchange row 1 and row 3. Now, when we interchange two rows, it does affect the determinant, and it's going to change the sign. So we'll have to keep that in mind when we finish. Our next step is to zero out those entries. So I'm going to take row 2 and replace it with row 2 plus negative 2 times row 1. I'm going to take row 3 and replace it with row 3 plus negative 9 times row 1. And then row 4 is going to be replaced with row 4 plus negative 3 times row 1. First row stays the same. And there's our matrix. So now we want to zero out those entries. So I am going to take row 3 and replace it with row 3 plus negative 16 over 3 times row 2. And then row 4 is going to be replaced with row 4 plus negative 5/3 times row 2. 1 and 2 stay the same. So we're going to have 0, 0. I got negative 40 over 3 here. And negative 40 over 3 here. Last row, 0, 0. And I got 1/3 and negative 14 over 3. So be careful when you type these in the calculator. Make sure you put parentheses around fractions. Now, in both of the last steps, because we replaced rows with the sum of that row plus a multiple of another row, the determinant is going to be unchanged. So it's unchanged in all three steps in that previous step, and it's going to be unchanged in the step we just did. So our next step is to zero this guy out, but I'm going to do a step before that. It's going to be so much easier if I turn this guy into a 1. So I'm going to do that. Now this is going to affect the determinant, so we'll have to undo that. But it's going to make it easier to figure out how to get rid of this entry. So sometimes we got to go for easy instead of less steps. That's going to give me 0, 0, 1, 1. That's going to be nice to deal with. And I'm just going to have some 1/3 down here and 14/3. The determinant has been changed. It's been changed by a factor of -3/40. So we need to keep that in mind. And then our last step would be to take row 4 and replace it with row 4 plus -1/3 times row 3. So now we've got this nice upper triangular matrix. So once again, I'm going to call this matrix B. So if we wanted the determinant of B, well, that's just going to be the entries down the main diagonal multiplied together. So it's going to be 15. Okay, but remember the goal. The goal is to find the determinant of A by reducing to an upper triangular matrix. So let's talk about how the determinant has changed. In that first step, the sign has changed. So we're going to have 15, but we're going to have to change the sign. So let's multiply by -1. In the second step, these row operations did not change anything. Same thing's true with the third step. In the fourth step, we changed by a factor of -3/4. So to undo that, we're going to multiply by the reciprocal. And then in that last step, because it was a row plus the sum, a row plus a non-zero multiple of another row, then the determinant is unchanged here. So there's only two things that change the determinant in this particular case based on the way we did it. There are a lot of different ways to do this. If you approach it a different way, your determinant may change in a different way, but your final answer should be the same. So this, interchanging those two rows, changed the determinant, and then this, multiplying a row by a non-zero multiple or non-zero number, changed the determinant. So we have to undo all that. So if we undo all that and multiply this together, we're going to get 200. And so that is the value of this determinant. And we did that without having to do any kind of expansions. So in real life, where would this come in handy? I would say probably programming. If you have a big matrix and you're trying to find the determinant, the row operations can get tedious to program, but Gaussian elimination is not as bad to program. So you could set it up to put your matrix in REF. Maybe you will eliminate some round off error as opposed to finding determinants of many more matrices. So there are pros and cons to everything that we do, but that would be one application that I could see.